Okay, so in principle you did this homework exercise. And notice that again we have a column for the matrix, a column for the permutations, and a column for the Gauss transforms. And finally, a column in which we accumulate an integer vector that tells us how rows were swapped. Now in this particular example, we immediately run into trouble because there is a 0 that we need to divide with. Now, we will have to swap with one of the other rows. Obviously, we could swap with the second row or the third row, but we need to make things systematic, and it would be difficult to deal with a lot of different students making different decisions there. So we're going to adhere to the rule that it is always the first row where we find a non-zero with which we swap. So, what permutation matrix accomplishes that? Well, it is the matrix that swaps the first row with the second row and leaves the third row alone. To indicate this, we don't actually need to store this permutation matrix. All we need to say is at this stage we consider this row 0, we consider this row 1, and we will store a 1 right here to indicate that it was the row indexed with 1 with which we swapped. When we then do that, we get a new matrix. That matrix has the first row as its second row. It has the second row as its first row. That's what the permutation did. And it has the last row as its last row. Now we need to compute the Gauss transform. To do that, we view this as a vector. We divide it by the element on the diagonal, in which case we get the multipliers 0 and let's see, 6 divided by 2 is 3/2. I failed to use nice numbers this time, but such is life. And then we recall that we need to take the negative of that in our Gauss transform. So we get a new matrix. In that matrix we have the original, well, we get the first row from here because that doesn't change. We should have carried the 1 down here. And what do we get now? We need to do 0 times the first row and subtract it off of the second row. Well, that just means that the second row is left alone. And we need to do minus 3/2 times the first row and subtract it off of the last row. Minus 3/2 times 8 is minus 12. Minus 4 is minus 16. Minus 3/2 times 6 is minus 9. Add 2 to that, we get minus 7. And what we would like to do now is actually, in small letters, indicate what the multipliers were that we computed. And we overwrite the zeros that were introduced with that. So if you look carefully, that's done in red. And I'm trying to write that relatively small. And we should carry this 1 down here. So now the question is, with which do we need to swap this row in order to make sure that there is no 0 there? Now we could go ahead and swap, there's no harm in that. But remember, we're just going to swap with the first row where there is no 0, and there's no 0 there now, so let's leave everything alone. So the permutation matrix that accomplishes that is just the identity. And to indicate that we didn't swap, we put a 0 here, because it's the row indexed with 0 at this moment, relative to the current row, with which we swapped. Then we get down here, and we now need to compute another Gauss transform. How do we do that? We view this as a vector. We divide by the element on the diagonal, so that gives us a minus 4. But then we need to negate that, and therefore we get a 4 here. The matrix stays. Okay, so actually what we should have done first is we should have said, oh, we permuted here, but we didn't really, so we should have simply carried this matrix down as such. Multipliers right here. vector that tells how we permute it right here. And then we should have asked the question, what is the multiplier we compute? That's minus 16 divided by 4, minus 4, but then we negate that and we get 4. And then down here we get the new matrix 4, 8, 6, 4 minus 2. This better become a 0, but we're going to put the multiplier there, so we'll leave it alone. And now we need to do 4 times minus 2, which is minus 8, to which we add minus 7, which is minus 15. And then we want to overwrite this part with the multipliers. And we carry down the information about how the pivoting happened. And at that point, we're done.